Hey guys, this is Ben Bolton with CG Tuts Plus, and today we're going to be starting off this knife series with the high poly tutorial. So, without too much exposition, let's just jump right into this thing. This is our reference. We're going to be starting with the blade arbitrarily, and we're just going to start laying down a plane here to get that shape out. So, the one important thing to remember if you haven't done a lot of high poly modeling yet is that it doesn't really matter what your poly count is. And that probably seems obvious, because we're adding a turbo smooth or millions of polygons. We're not really, being careful about the try count. But sometimes, if you've done a lot of low poly modeling before you get into this, you're still working with the mindset that you need to create everything with, the minimum number of edges and vertices and faces. And you don't really need to, you can abandon that mindset to a good degree when you start working with high poly stuff. And basically, that just changing your mindset, like in that simple way, will really allow you a more easy go of it when you have to do something like this. For example, I'm just creating the side of the knife here. This area is totally flat, and yet I just made it with like two loops here and bridged in between. And if this was the low poly model, that would be a lot of wasted triangles. You wouldn't need any of those to actually change the form of anything. So they would just be sitting there being pretty, doing nothing. But with high poly modeling, it's actually going to be useful to have those there because I can run connections down them later and tighten up some edges, which we'll get to in a few minutes. So for now, I'm just finishing up the blade here. Then we're going to jump into our perspective view and start doing fun things. But yep, just gonna get the shape down for now for this step. Oops. Just a lot of extruding and welding at this stage. We'll get to a lot of bridging in a moment too. So now we're going to hop and do perspective. Grab the flat edge on the side here and just pull that out some. That should be good. Gonna grab a few of these edges. Oops. Extrude them to 0, which should line up with the blade. Yep. And then add a symmetry modifier on here. Symmetry, of course, just mirrors your model along a selected edge or a vertex, maybe. I only ever do it with edges, really, just a habit. But it's a good one to have, I guess. You just pick your axis to revolve around. It's Z for me in this case. And there we go. That's our knife blade. So now we're gonna have some problems when we first throw Turbo Smooth on here. Namely, that it just becomes more of a big blob than, a sharp, finely honed blade. So in order to fix that, what we need to do is select these rings that I made before by just selecting one edge and then going to ring. And then use connect and create a supporting edge using that. And do that twice here. And what this does is it more densely, you'll have a higher polygon density around the hard edges that you create with this connection thing, and because of that, when you subdivide, you'll have a greater level of subdivisions in those areas with the higher density. Or not a greater level of subdivisions, but rather the subdivisions that you do have will cause those greater density areas to have more faces and therefore be sharper. So if we look at it now, and It helps with subdivision stuff too, to add some specularity to your material, which we're going to just go to this and there, and see, you can see the forms more clearly. So that's pretty good, that's pretty flowing. There's a few areas I just want to tighten up still, which is the back here. And I think right there. And that should give us a pretty good result. Yep, alright, so there's our blade, but there's still something we haven't done with it yet, and that is this indent here. And we are going to do that indent, but we're not going to actually cut it into this surface. To save time, we're going to use what's called floating geometry. Floating geometry is when you just you take your detail, and instead of actually cutting it in and attaching it to the surface that it's on, you instead just hover it, float it slightly over that surface. And the advantage there is obviously you save time because you don't have to, you know, actually cut it in. But you get the same result when you're baking, because what happens when you're baking is that the rays from the cage, the low poly cage, will project straight in from the side here, which means that you won't actually be able to see that the geometry is not attached to the surface. So you'll get the same quality bake, only half the effort. And that'll become more obvious later on when we actually get to the baking. But it's good to keep in mind, obviously, in high poly modeling, just because it can save you a lot of time. So I've got my 2 halves of a sphere here that I've been making. Just going to bridge them, flip the faces, get it into position. Needs to be a bit longer. And then just so we get some nice edge highlights on the left, on the side, I'm just going to extrude a few rings out of it. And to make sure it retains its shape, I'm just going to add a few supporting edges in there. Now, we move it, or collapse it a bit, we move it right next to the surface we want it to float over. And then we'll go into our low here, attach it, then watch the symmetry and turbo smooth get applied. And there you go. When the baker looks at this from the side, it's not actually able to tell that that's not carved in, that it's just floating. It looks exactly the same, but it didn't take anywhere near as much effort. So now we're going to get started on the actual handle. And to do that, instead of starting from the side like we did with the blade, I'm just going to work around the edge of it. Being careful to add more polygons, more edges to areas I want to keep hard, and just in doing so reduce the number of connections I have to do later on. As you can see, I'm just keeping areas dense, so I want to be fairly hard. And we're just going to follow the outline here. This is a pretty easy shape. If you tried to tackle this from the side, though, starting with the side first, it might be more difficult because of areas like this. You'd have to bridge things and connect them in awkward ways, but there's a much easier way to do this with subdivision surfaces that we'll get to in just a moment when I finish up here. It's much easier because you don't have to worry about n-gons in certain situations. So we can actually leave most of the side here open. Not actually open, just capped and without lines through it. And just to make this a little more interesting in the end, I'm going to add a bevel to it. Give it a more rounded silhouette. Alright, now to finish off these sides. Actually, let's add a symmetry modifier here, so we only have to do this once. Modifiers, mesh editing, symmetry, my best friend. Now we're going to select this ring border, scale it in. Oh, I'm on local. Scale it in and out a bit. Max doesn't always scale in perfectly, so we're going to have to manually just fix this up a bit, improve the consistency of it. Shouldn't take too long though. And basically what we're doing here is just creating the supporting edge around the edge of the entire thing, but we're doing it by extruding in a border and then using that border as the supporting edge. Then we'll scale it in one more time and then cap it off, and we should be good to go without having to fiddle around too much with quadrifying everything. We'll get the same result but less effort, which is always good when you work by the hour, or when you just want to finish things quickly and be the envy of all your friends and your boss. So, okay. Now we're just going to scale this in one. Actually, I'm going to move these up a bit. Then we're going to scale this in one more time. We do not have to be precise with this one. And then cap it. So there we go, that's the side. We might have problems with turbo smoothing. Yep, we've got a few. Alright, so we've got some stretching here from the turbo smoothing, and that's caused by mostly just convex shapes here. So all we have to do to break that up, we don't have to cut everything up. We just have to give it a few hints. There's some areas to play around in on these convex areas, or concave areas. We just basically, Max does not like subdividing long triangles, and it tends to do it wrong. But so long as we keep areas mostly convex, it doesn't really matter, because things can't cross over areas where they shouldn't and leave those big, long, black, ugly artifacts. So we're just going to give it some hints here, connect a few things, and there we go. All set, all clean. That's the base of our handle. Let's widen it out a bit. But otherwise, it looks pretty good. And then I believe there's some floating stuff to add there. Whoa. This should be left. Alright. Now we're going to deal with this floating stuff. These are just holes, I believe. We can do those with floaters as well. We're just going to create some 8-sided cylinders. No height segments. We'll attach all of these. Delete everything but the front caps. Scale those in so we know they're all on the same X coordinate. Move them back close to the knife. Going to inset twice, just to get that nice edge highlight like we did with the blade indent. And then bevel in. We don't want to do a straight bevel with no outline, because then the normal map won't pick up the difference in height between the side and the inset part, because it won't be able to see the transition. So we need some outline there so that there's a transition, so it translates well to the normal map. And that goes for bolts that face outward too, it goes for everything. Alright. And then we're going to just we'll delete those faces because this is supposed to be a hole, so there wouldn't really be a surface back there. Then I'm going to select all the sides and add one supporting edge near the top. Then we'll attach it, or we'll try to. There we go, attach, yes. And just move them in a slight bit more because we can afford to. And there's our holes. Then there's also a couple of bolts here, we'll just do those quick. All we need is a sphere, 8 segments. We'll lop off the bottom half of it, extrude out the border twice, scale it in some, and voila. There we go. Those are our bolts. Attach them, and we're all set. So that's the base of our handle. And the blade. So now all that's left is to do the actual wooden grips and the latch thing. This. So we'll start with the grip. This is the most complex shape we've run into so far. Just looking at it, I think the best way to start this off would be with a cylinder, just because the entire surface is curved. So we'll do that. Maybe a few more sides on it. 12 ought to be good, I think. Alright, we'll just delete half of this. We'll spin it and get it roughly into position. This is a very complex shape, so it's going to take some wrapping our brains around to do it. There's 4 indents along it, which means we're going to need 3 connections, and then between each of these connections, 2 connections. Move a few of these up. The 2 that we created between each of the main connections will move up. I'm not totally matching the reference here, but that's not as important as getting the actual feel of the object down, getting it sort of close enough to be recognizable, especially with something complex like this. You could probably take more time to get it perfect, you know, but this is just a tutorial, so I'm trying to get the basics out of the way here. We'll just match up the shape, which is tough on the back end here because it's going to move over into a few other lines, but it won't be a big deal. Plus, it'll let us run supporting edges later, which is always good. So, okay, looking good there. Alright, this area is different. This whole area tapers in towards the end, which means basically we just taper it all in. There we go. Oops. And that should do it for that. I believe we can flatten this out a bit. Yes. do some eyeballing work here. I want it to stick out enough to be visible, but not so much it's kind of silly looking. And then towards the end, we're also just going to taper them inside the actual handle. Over here, I believe, was solid. So we'll straight up move that in. Alright, now we throw the subdivision on it. Turbo smooth. It comes out pretty well already. Could maybe use to be a bit more tight in the back, so we'll throw a supporting edge on there. Alright, we could also just chamfer that if we wanted, which would mean just selecting this loop, chamfering. It'll probably give fairly equitable results, but the thing is, if we wanted to change that later, there'd be no easy way to. We can't easily move this chamfer without, messing things up. It doesn't preserve the original line, it alters it. So the benefit of using a supporting edge that we just add with a connection is that later on, if we decide we don't want it, we can just select it again, boom, it's gone. And we still got that original curve there. So that's why it's almost always better to just use a supporting edge rather than a chamfer. So might be interesting looking too if we bring these indents in more, just to emphasize them. We can work with Turbo Smooth on too if you have a key set up for view final result, which is what I'm using here. We can just jump back and forth between the low poly and the Turbo Smooth, which means we can move these edges around and see the final result at the same time, which is very useful. So yeah, we're going to move these in, as well as the ones below them. For a more extreme effect there. Maybe a bit too extreme. That ought to be good, I think. Alright, so there's our grip. Actually, just even that out a bit. Alright, now we're going to delete the Turbo Smooth off this. We're going to set the pivot under the constraints. I believe this is hierarchy. Under the hierarchy menu, we're going to affect pivot only, center it to 0 on the x-axis, duplicate the entire object, go to Tools, Mirror along the X, and there's our second one. So that's two grips. We didn't have to connect them in the middle and use symmetry, which will be fine later on. These are just two ways to do effectively the same thing. And one more thing, we have to go to Tools, Reset X Form, Reset Selected, and collapse that, and then flip all the faces. You have to do this every time you mirror something, or else you'll run into problems later on. I'm wondering if this isn't centered. It's not, right? At some point that the grip got uncentered, so we're all set now. So now we're just going to attach these, and there we go. So that's the grips. Now there's only one part left. Actually, oops. I have forgotten one thing here, so I'm just going to add some of this curvature in. And then we'll move on to the lapel pin feature. There we go. Alright, let's That's more interesting looking, I guess. Now this final feature, it's some sort of clip, I guess, just to help you hold on to it. So we're going to start with this because this is a pretty easy area to start with. We'll drop down a cylinder. We're going to have to do these extra little half cylinders on top of it. So to facilitate that, we'll drop a 14-sided cylinder so that we get these flat edges on the top and the bottom. We also could have rotated the 12-sided, I guess, but this is just more straightforward. Alright. Some reasonable thickness on this. And we're also going to delete the end caps because we don't need them. Extrude this in. I'm not sure what this little object in the middle is. Some sort of rotation device probably, but we're just going to build it into the rest of this for simplicity's sake. We're going to need supporting edges along the edges there. But before we add supporting edges to the side of this, let's build in those. Grab a cylinder, set it to, I don't know. We need enough sides in this for it to maintain its shape easily without adding too many supporting edges that'll break this one's curve. So we're just going to, I think 12 will be good for this. 12-sided cylinder. Just align these. Alright, that did the opposite of work. So, delete that end cap, and that one, and all of these faces we're not going to need later. Grab this, attach, delete this face. Alright, now before we do any connecting, I just want to make sure that these are all in the same x-coordinate, which they probably are not. Yep. We can also just scale them all to the same thing. A bit quicker. And then we'll target weld these edges, and we should be all set. A lot of turbo smooth just to see how this is working. Yikes, that is pretty ugly. So we're going to just select some of these edges. We don't want all of them. Basically we just need these and there we go, that should work pretty well. Also add a supporting edge right there. Now the reason I can do this, because as you see this is leaving pretty major n-gons right here, but it's not going to affect the smoothing of anything because, as you can see, because we've got this insulation here. We've got, basically you need one supporting edge between every 90-degree angle on each side of it, and then anything between that and the next supporting edge 90-degree angle combination is insulated, which means I could do like whatever I wanted in these areas I could add just random connections that didn't do anything, that were just horribly placed and everything, and they would have absolutely no effect on the actual outside shape. So because we have these supporting edges just to keep our edges hard anyway, it allows us to do things like this, which is harden up edges that are coming off of it at a weird angle without affecting this bottom circle. So that stays round while this has a strange shape to it. And that's extremely useful and definitely an important concept to understand if you want to make your life a lot easier when working with high poly stuff. You don't have to stick to quads. People will tell you stick to quads all the time. Let this be proof you do not need to. You do need to understand when and where you want to use quads and when you don't. But as long as you get that, through your head, you're all set. You don't really need to stick to it too much. So I'm just going to collapse this. These edges are causing mad problems, so I'm actually just going to get rid of them. And then we're going to start on the alright, they don't want to be gotten rid of. Oh, there's no faces there. Alright, well, we'll just cap this off. Easy solution. Now, we've just got this little lever clip thing to deal with. And actually, in order to deal with it, I'm going to back up a few steps and get rid of these supporting edges, just so we can have a clean base here to start with, without having to worry about, having multiple quads to line up during this entire process. Yeah, so we're going to take this, even everything out. We'll get the elevation right later. For now, I just want to focus on moving this thing out and getting the width right. It's a very strange shape, so definitely a useful application of plane modeling, just extruding and following it, trying to match it as best as possible. Alright, and we'll just make that way. Now we're going to actually have to bring this out. I'm guessing well over this handle grip thing, wooden grip. And that looks about right. Now in order to deal with these holes, I'm going to have to use these as supporting edges, unfortunately, and just get them out of the way so we can add those holes there. And that'll become apparent pretty soon. Basically what we're going to do is we're going to use the insulation technique I was just talking about. That's what I'm moving these edges down for, in order to drill holes straight through this without having to worry too much about how it'll affect the subdivision of the rest of the object. So we're just going to get some cylinders of roughly the right size with as few edges as possible. I think 6 is probably about as low as we can go. So 6 of these straight through. Select them. In fact, just to work on this one part most easily, I'm going to detach this, and we'll later reattach it, but I just want to detach this to its own object, this part of the clip, and then for now just hide everything else. Sometimes this can be useful if you just want to focus on one particular area, even of one particular object, and just get that done without worrying about any other distractions. And we're going to attach all this together. Delete these faces. Get the x-coordinate of them, of the faces, and then move these in. Oops. I have to select vertices so we can actually do this. Move them in. Alright. Now we're also going to add a symmetry edge here. This is where it starts getting crazy. Add a symmetry edge in this part of the model that we cut off the part of the other model. Get its x-coordinate and move these there. Okay. Yeah, this will work. Now, delete those faces. We're gonna have to flip all of these faces. Right there. And that'll be the inside of our hole. Now, we're going to have to select the borders of all these circles. Extrude them out twice. Connect each of them. Gonna add one more edge here just to make this work a bit better. In fact, I'll add a few edges. Since we're effectively cut off from the other side, the top and the bottom won't be directly connected, so they can have different numbers of sides in them. It's no big deal, so as long as we've got that, we might as well make it work for us. Make this curve a little better defined. Oops. Alright. Go back to connecting all of these. Now, we just need to connect these enough that we have a non-concave n-gons wherever possible. So what we're going to do is create this face here, and this will give us the bare minimum we need to actually connect to the rest of the object when we unhide it. And then we're just going to basically connect these with just, basic regard to keeping everything as relaxed as possible. And until all we're left with is convex shapes. Triangles mostly. We'll cap those. I don't know what's happening here, so just get this back on track. Add a symmetry modifier. And then unhide everything else. Actually, before we unhide everything else, and before we get rid of that symmetry modifier, let's just clean this up here. Get these supporting edges right before we can get too far into things. Pretty simple. Alright. Now we're ready. This should subdivide well by looking at things. This whole area is messy, but again, each circle is insulated from everything else by these two supporting edges here, and the edges are insulated from the circles and all this mess by the supporting edge. So the edges won't be hurt, the circles won't be hurt. So basically it's all set. We're going to have an absolute mess in this area, but it doesn't matter at all because all of the edges that we can actually see changing, everything that actually has a change in contour, is totally protected or insulated from everything else. So now we're going to go back, unhide everything, rehide everything except this little latch, and just finish the job here. Oops. Gotta delete that symmetry line. Alright, now attach there. Select everything in that general region vertex-wise and weld it. Check, make sure we've attached it. Yes. Alright, so now we've attached that. That's working all set. But we just need to work this back area a bit more. And basically all we have to do for that is, since this area right here will actually be inside of the knife handle, the only parts we need to make sure have a proper back are the ones that are sticking out. Which means all we have to do is extrude these down and then bridge everything. Or cap, whichever. And there we go. That's our latch. Actually, I believe there's some bolts right there. We'll do those in a second. So unhide all. Re-add our supporting edges here. And hope this works. Yeah, I think that'll work. There we go, that should merge seamlessly in. We'll just do it down here as well. And cross our fingers and turbo smooth it. Alright, looks pretty good. Maybe a bit of messiness here, which I believe we can solve with just some creative supporting edges. There we go. That's pretty good. And there we go. Our clip is all set. We've got the holes drilled in it. We've got yeah, the holes being drilled is probably the main feature there, but we've also got circles being attached to other, or cylinders being attached to other cylinders. And that'll almost do it for this model, for this high poly model. All that's left is two things. One, we're just going to grab these, straight up detach them. We're just going to use this bolt that we already made, save some time making another one by just grabbing the one we already did, scaling it down, making another one, and then attaching. Alright, now I seriously doubt this has a whole other clip on the other side, but if this is a rotating mechanism, which it probably is, then it's going to need something to rotate around on the other side. And besides, we just need something to fill up this space. So we're going to add one more piece of floating geometry. This one we're just making up. And for this thing to rotate around. And that'll about do it. Basically, it's especially with high poly stuff, I guess, just because it stands out more. But you want to, when you're making a high poly model, you got to remember that the only reason you're making it is for the normal matte baking. and occlusion or whatever, but primarily the normal map baking. And to that end, you got to be thinking, like, what am I getting out of this normal map? How can I maximize the returns I get for all this effort that I'm putting in? Because you're basically modeling the same thing 2 times. The first time high poly, and then the second time, of course, low poly. So you've got to be thinking about, maximizing the returns for all the effort that you're putting in. Basically, you want to get the most out of your normal map that you can to justify its use. And so the more detail you have in there, the better. It's a general rule of thumb. I mean, don't go out of your way to just, add in random detail and stuff unless you're doing sci-fi work, because if you do that, it'll look like you are doing sci-fi work, which can help undercut realism. But generally speaking, more bolts, more holes, more grooves, more detail, better. And I'm just going to finish this off with a little bit of an interesting design here. Kind of just making it up as I go, but this is basically the other end of this, what this rotates around. So we'll see how this subdivides. Get a few supporting edges in there, just to get rid of the lumpy look, and then we'll be all good. Alright, so there we go. This is our knife. This is the high poly. In the next episode of this series, we'll be working on the low poly. We'll mainly be generating it from this model, degenerating it, but some parts we'll be creating new. Then after that, it's on to baking and texturing. But this is definitely the crucial first step, so I hope you guys have managed to learn something, and I'll see you in the next tutorial.